Hello, this is part 10 of creating a 2D platformer. This session we're looking at, well, if we press play here we can have a look what we're going to do. So at the moment we've got our skeleton dude moving from point A to point B with just his idle running. So if we look at animator, we can see that his idle is just running, and we haven't implemented the walk animation. So that's something we do need to do and do need to look at for starters. Okay, so if we are going to add our walk animation, what we need to do is get it initially set up. So if we go to animation, let's click on our skeleton idle, and that brings up animations. We can then go create clip. Let's go skeleton. Oh no, let's put it into sprites, animations, enemies. Cool. And then we'll call this. What did I call the first one? First one was called idle skeleton, so I'll call this walk underscore skeleton, and click save, and that will save in the right place. Cool. Okay, so let's find those frames. If you're using my assets that you from itch.io, you can go to make sure you're not on the GIFs and you actually go to the sprite sheets. Then what I'm going to do is click on walk, and as you can see, I've just to save some time already cut these up, ready to be taken over to our animation timeline. So what I'm going to do is click record, and let's click on this dude and keep selecting with Control or Command every single sprite. Cool, lovely. Once I've done that, I'm going to drag them into there. Brilliant, fantastic. Also, another thing to check is if you click on your walk, make sure that the pixels per unit are 32. The default is 100, so you change that to 32, then click apply down here. But we're just making sure that this has already been done. This is something I've done previous. So once that has been done, as we can see, if we unrecord and press play, his walking is he's going a mile a minute. So what I'm going to do is just change the sample down to 12 again, press enter. That evens out lots of different things. There we go. Fantastic, nice, steady walk. And you can see I've got this tiny little pixels or line of pixels that pop up here on the scene. Yeah, this is my issue where I've just automatically cut these. I've set it to automatic. Maybe I should have set an appropriate cell size. Maybe if you look at it here, it's actually 286 by 33 pixels. So I could have changed that to 1 pixel more instead of 32. But that's fine. You know, for the purpose of this video, that pixel flying around there, this guy's still doing his main job, so I'm not really worried about that. Okay, so if we go to our tab over here, our animator tab, we can see that now we've added our walk animation to the show. So what we're going to do is create transitions from idle to walk, and then back from walk to idle. So what we do is right click on that, make transition, click onto that, right click again on the walk, and do a transition back, just like that. Okay. What we're going to do is we're going to let idle to walk just run. This is going to be absolutely fine. As you can see here, if I press play, then you go straight from an idle to a walking in our little preview. That's fantastic. What I may change is that our transition duration is at 0.25. So there's a kind of blend, and if you do have a blend between animations, that's fine. That's more likely though going to be with vector-based rigged animations where the IK is changing from one to the other. We're more changing states, so we're changing from one picture to another picture. So what we're going to do is just change that to 0 for pixel art. But for vector though, you can keep it or even increase it. Okay, so we're going to do the same with this transition as well. Change that back to 0, and then if we press play, it goes back to an idle. So from walking to idle, that's working absolutely fine. Brilliant. Okay, so in this session, we are going to look at a piece of script called, like a state essentially within Unity, which is get current animator state information. And what we're going to do is we want essentially now from this skeleton, we want him to, when he's moving using vector3.move towards, we want him to walk. When he is idle, we don't want him to walk, otherwise he's going to be standing still, but looks like he's going to be moving on a conveyor belt. We don't want that. So we have to tell Visual Studio what is idle and when idle is happening, which is what we're going to do in today's video. So this is why we've just set this up and set up our idle to walk. Okay, so from our transition from walk to idle, we need to create a parameter. Okay, so once we create that parameter can be called up within Visual Studio, and then within Visual Studio we can manipulate that how we like. Okay, so what we're going to do is go to the plus under parameters and click trigger, and we're going to make sure that our trigger is called idle, and that is the most essentially the animation or trigger we want to call up. If we can find within Visual Studio what idle is, from there we can go and as I said, manipulate it, call it up and freeze it when our skeleton is standing. When he's just standing there, make it idle. When he's moving, we can implement that walking animation as well. So what we're going to do is, now we've created our trigger, which is idle, I'm going to scroll down here and under my conditions just click this plus here. Once I click that, idle will automatically pop into our conditions, simply because this is the only parameter that we've created. So it's as simple and as easy as that. Okay, cool. Once we've done this, we're going to make sure has exit time is also checked, as Unity and Visual Studio is going to be checking our script for a stop, or our animation for a stop. And if we don't have has exit time checked, it won't find that stop, and we will just keep moving and the script won't work and will automatically create a bug. So that's another important factor, and that's for both transitions as well. We're going to make sure those are checked. Okay, so what we're going to do is jump into our skeleton script that we created last week for our enemy, our first enemy script, as we can see here. So I'm going to zoom in a bit so we can see what's going on here. So what we're going to do is not fix this script because it's already working, but optimize this script, make it a little bit more simple and easier to understand. So the first thing we're going to do is we're going to create a brand new method underneath. So under here we're going to create a method called void movement, and with our open and then a close brackets and then our curly brackets. And essentially what we're going to do is as you can see, we have our private void start, our public override update method, and our method that we've just created called movement. If we start compacting, if we put everything into update, because obviously when we want everything to run every 60 frames per second, we want it to run throughout our game. If we put everything in update, eventually, if we keep adding things, the game will eventually lag. And this is because of update. Everything is going on update and reading constantly. So what we're going to do is sort of make it, give update method a little bit lighter work to do. And what it's going to do is essentially just run our other separate methods for us. And then those methods are going to run separately, creating better optimization and less lag when we come to putting our game all together. So hence why we've created a custom method here called void movement. So next thing I'm going to do, I'm going to take all of this. Actually, just take it from there. All of that. Control C, Command C on a Mac, and paste that into movement there. I should have cut that really. That's fine. I'll just highlight that and get rid of that like that. And then I'm going to call up movement within update. So what I'm going to do is write movement. There it is. It pops up. Open bracket, close bracket, semicolon. So as soon as the script runs, update will run our movement method, which is down here. Okay, so we can still do a little bit more of optimization for our script. So what we can do is instead of using a bool to state, to stop and to start, we're going to use a vector3. So let's create a variable for that. So if we call this private transform and call this oh no, it's not a private transform, it's a private vector, apologies. Private vector3, just said vector3, and we're going to call this underscore target. Just like that. And what we're going to do is implement this into our script. So what we can do is actually we can totally delete that, get rid of that, and get rid of these parts as well. So what we're going to do is if we simplify this down and say if our transform.position equals point A dot position, so if we're moving to point A, what is our target going to do? So our target is our vector3, which is, so if we put this script on any object, it will, that becomes our vector3 object. So our target is essentially our object. So we're going to say target underscore target is going to move to point B, because if we're at point A, we want to move to point B. It is as simple as that. Point B dot position. There we go. And then we're going to do the other way around. So we're just going to say underscore target equals to point, capital, to point A dot position, semicolon. Lovely. That is looking good. Okay, so we haven't stated what target is actually doing. So what we can say is transform dot position equals a vector3 dot move towards transform dot position target, which is then going to be by our speed, and then times by time dot delta time. Lovely. So that's how our movement, that simplified movement, is going to work. So what I'm going to do is sudo out switch. We don't need that anymore. So if we quickly save this, we've added our variable, which is good, and hopefully we should still have the same thing that we had before. So our skeletons should move from left to right, and the animations will still be messed up, but that's fine. Let's have a look. Cool, lovely. Well, it's going through each animation, I think. Oh no, I've added on that idle, so he's just walking back and forth. So there's a slight improvement there, but obviously we still need to use the state info to find out what idle is. But that's working, that's good, fantastic. So that's good, that's in movement, that's fine, that's brilliant. So let's have a look. We need to find now, and now we've optimized this and simplified our script, we now need to move on and have a look at how do we find out idle? What is idle? So what we're going to say is, first of all, we need to create our animator within our script. So we need to add a new variable, which is going to be animator, and I'm just going to call this anim. Makes things a lot easier. We're then in private void private. Why has that done that? I hate when it does this. Helpful. Come on. Don't. Why is it doing this? So weird. Let me type this out quickly and see if it fixes itself. So what we're going to do in our start, there we go, it's fixed itself. Within private void start, we're going to say anim is equal to the get component in children, because obviously if we have a look on Unity, we can see that it's a parent, it's a child to our parent in animator. So if we click on the child, there is our animator. Cool. So we're going to call up our animator. We can then say in our update, so we'll do this in update so not confuse things. We can say if bracket anim dot get current state info is brackets to 0. So what I'll do, I'll write this out and then I'll explain it. It'll be a lot easier. Is name, and let's just have a look at that name very quickly. Idle underscore skeleton. Brackets idle underscore skeleton, not skeleton, skeleton. Lovely, funky. Okay, this is what's happening here. Got 2 brackets. I'll just go in is name. I've called that. Why doesn't it like those brackets? Oh yeah, dot. There we go. Silly. Cool. Lovely. So let's just clean this up. What's happening here? Let's get rid of that. Cool. Lovely. And just write a turn. So what have I written here? In my public override, I've said if our animator find our current state. So we're going to find our current state of our animator. Okay. So what state are we looking for within our animator? Well, we said the idle because we don't want our skeleton to move while it's in idle. So it's good to find idle, and then from there we can manipulate it. So I've said get current animator state info 0. The reason I've chosen 0 is you can have layers in your animations. So here we've got our base layer and there are animations. So there's many examples like Uncharted, Batman Arkham series, where you have different styles. You go into different modes, so fight mode, climbing mode, flight mode, climbing, shooting mode for Uncharted and things like that. And these different kind of modes have all different animations working with the same kind of buttons. So shoot, maybe in the shooting mode, it would be R1 if you're on a PlayStation. But then if you're in a climbing mode, R1 could be climb. So then we have these different layers and these that build up. So one could be called shooting, climbing, etc., etc. So, but within Unity, that still works from 0 to 9 on numbers. So because we haven't created any other layers at the moment, we're just on our base layer, and our base layer is 0. Obviously, if we created another layer and we wanted to get the current state info of that, in this brackets, we would put 1, 2, 3, 4, example, or depending how many layers we had. We then have to say what the name of the animation is, and we're saying is name idle skeleton, okay? And that's exactly what is here, and that's very important. So double check this. If you've just typed it out, make sure you've got a capital I. I know it's not the same font here, but that is definitely a capital I underscore skeleton with a capital S as well. I'm then asking it to return. So what I'm asking it to do is, if we have a look, I googled this earlier, So what does return mean? Functions generally have none or more inputs or parameters, and return is none or one input, one output. So return statement simply specifies what the output returned from a function to a function is. So that is quite confusing. So essentially it's just returning back to idle. It's not doing anything else. It's finding idle and returning back to it. That's perfectly fine. We can do that. That's perfect. We can work that. So sometimes you might have to implement the other part of the script, but this shouldn't change anything. If I'm from the top of my head, we should play this and let's compile. Cool. No, that's still the same. That's perfectly fine. We haven't called up animator yet, and we haven't set that trigger specifically. Okay. So that's what we're going to do now. Okay. So underneath our movement, we can add our set triggers. Okay. So if we add our set triggers, we've already got anim. So what we can do is simply go to anim.set trigger. Where's trigger? There it is. Anim.set trigger, and the animation we are triggering off is idle because we've already triggered it. It's already within our parameters. And again, anim.set trigger. We're then calling up that idle parameter. Cool, lovely. So if we save that from this, press play. Oh, come on, press play. Come on. Lovely. So as we can see, what is happening is he's walking, he's finding that idle animation and stopping. So there is no movement on our idle animation at all. And we can see this if we click on parameter as well. Every time that idle underscore skeleton pops up, he does not move. Which is brilliant. That's what we're looking for. Awesome. Okay, so one of the last things, more of an aesthetic than anything else, because we've got the main implementation in, is flipping the sprite. Because obviously he just looks like he's more moonwalking backwards at the moment. So we need to fix that. So he's doing it. This looks perfect, but he's not flipping when he gets to the end of point B. So that's what we need to do. So let's have a look. What can we do here? So what we're going to do is create a brand new private sprite renderer. So let's call up our sprite renderer just like we did for our player. I'm just going to call this underscore sprite just like I did for underscore target. And so we want to flip our sprites. So what we can do is let's initially again do underscore sprite, call up sprite renderer in start. Again, it's under the children because it's exactly where the animator is. And we just type in sprite renderer. Lovely. Knew what I was doing. Lovely. Okay, so where are we going to put that? We can add it into the movement and we'll add it into the top, just so it reads it first. So in movement, we are going to say if brackets underscore target equals to point A dot position. So if we are at point A, if we are going back to point A position, so if target is going to point A position, are we going to flip our sprite? Yes, we are. So we're going to put sprite dot flip x equals true, and else we're going to say sprite dot flip x equals false. It's as simple as that. Command or Control save that. Go back into our game. Loading. Press play. And hopefully we should have a lovely flipping sprite. There we go, right at the end. Cool, I hope you've enjoyed this video. If you are confused about anything, and I'm not gonna lie, I am quite tired today, and you're unsure about what's happening here with return or get current animator state info, or even this simplifying, optimizing our script down here, please have a look at Scripting API, Unity, that's what it's there for, Scripting API, and type in whatever you're thinking up here. So if we go get animator state info, what pops up? Oh, nothing, that's absolutely helpful. So get info animator. Is there anything there we go, that's better. We've got to put some spaces in. And then there's loads of different things. But what you could probably do is just copy and paste a piece of script from this, what we've done today. And so get current animator state info. You could probably copy and paste that into Scripting API and find it that way too, and to get a proper explanation from Unity rather than myself. Okay, next session we'll probably have a look at the player again and get that attack implemented and move hitboxes and stuff like that. Cool, hope you've enjoyed the video and I'll see you soon.